here to show you a little bit more about the comparison test. All right, 199, we've got to compare that to something. So let's first try to rewrite this. So let's take n factorial over n plus 2 factorial. So this is, n times n minus 1 times n minus 2 and so forth, right? Whereas this guy here is, n times n minus 1 times n minus 2, but it's also got n plus 1 and n plus 2 around it at the bottom. So all of these cancel, everything else cancels, and we're left with 1 over n plus 2 times n plus 1. All right. So what can we compare this to? Well, let's take a look at what else it looks like. Let's FOIL this out. So it's n squared plus 3n plus 2, right? So we have an n to the second power. So this looks like a p-series where our p is 2. So let's compare that. That equals this 1 over n squared plus 3n plus 2, right? We'll compare this to a known value of a p squared, so 1 over n squared. So how does n squared plus 3n plus 2 relate to n squared? Well, even starting with 1, we're going to have a larger value in the denominator, so this is going to be a smaller value. So since 1 over n squared plus 3n plus 2 is always less than or equal to 1 over n squared, and that's for all n. All right, doesn't matter what integer n we choose for that. So I guess we don't want the positive integers, because again, we're going from 1 to infinity there. Since we have this, and we know that this series is a p-series with p equal 2, which is greater than or equal to 1, it converges. And since we have, I guess we should throw a 0 in here. Since we have this, and we know this, that means that our series also converges. Okay. So let's look at the other one here. This one's actually a little easier. We don't have a lot of moving around that we have to do. So, n factorial is n times n minus 1 as we discussed, right? So if n equals 1, we have 1 factorial, which is 1, n equals 2, 2 factorial, which is going to be 2, 3 factorial is 6, we'll go to 4, 4 factorial, we'll multiply it by 4 is 24, 5, we get 5 factorial, which is 120, look right? Okay, so that's what we have for the first 5 terms, and we know that they're getting bigger and bigger from then on, but let's take a look at the other ones. For n squared, which is what I'm going to compare this to, for n equals 1, we get 1. That's the same. For n equals 2, we get 4. Well, that's not helping yet. Equals 3, we get 9. N equals 4, we get 16. Aha, we're back on top, right? N equals 5 goes to 25. And as you can see, our n squareds are not going to increase nearly as fast as our n factorials. So we have 1 over n factorial is less than or equal to 1 over n squared for n greater than or equal to 4. So it doesn't work for n equals 2 or n equals 3, but it does work for 4 and up. Again, this next one goes to 36, and this one goes to whatever 6 times that is, 720 or something like that. It's getting demonstrably bigger. So we have this, and we also know this. It's got to be less than or equal to 0. So the sum of 1 over n squared converges, which means our series 1 over n factorial also converges. And that's how we do these.